This is the final presentation for the Big Data Analytics at Columbia University, and the project title is Gender Recognition by Voice. And the dataset is from Kaggle website. And in our project, we will use acoustic characteristics like mean frequency and skew, etc. to determine the gender of a person. And the main part is that we will use three main classification algorithms: random forest, naive Bayes, gradient boosted tree, to test the accuracy of every of three algorithms. And at last we will do a prediction. And the motivation of our project is that gender recognition is a key part of identification, and the result of gender recognition can be used in many other fields like gender studies. And here we listed all the 20 characteristics of voice, and we can also have a look at our dataset. The first 20 columns are the 20 characteristics of voice, and the last column is the label, which is the class that we have to classify. And after that, we will do main feature extraction on the dataset because we want to obtain a higher accuracy. So here are two examples. All the red points indicates female and all the blue points indicates male. And the left plot is a plot for mean frequency feature. And we can see that in this plot, the red points and the blue points are plotted separately, meaning that that mean frequency is a main feature. However, in the right graph, which is the plot for first quantile, the red points and the blue points are almost in the same location, meaning that this is not a main feature. So after that, we extracted 10 main features to do our project. And the first algorithm we use is naive Bayes, and we use both raw dataset and the extracted dataset. With raw dataset, the accuracy is only 84%, while with extracted dataset, the accuracy is improved to 91%. So this indicates that is useful for for the naive Bayes algorithm.
Now let's look at the second algorithm, the random forest. From here we can see that accuracy is over 98%. And here is the decision tree. The random forest uses several different decision trees, and the final result is a merge of all the separate results. And here we can see that using all the features and only using the mean features have almost same accuracy. That's because the random forest randomly choosing data and randomly choosing features. It will produce a best combination of all the features. So the order or subset of the features doesn't matter too much. Now let's look at the third algorithm, the gradient boosted tree. From here we can see that the accuracy is about 98%. And from this picture, the left side is using all the features, and the right side is only using the mean features. They have almost same accuracy. This algorithm learned by misclassification, which means that the error will be decreased step by step. And the second thing is that it has some penalty parameters. When we test, we found that if we only use a subset of all the features, sometimes the penalty parameters may be very small, like negative numbers. So it will have to maintain the accuracy to be a constant level. And the third thing is it also uses tree ensemble, which it will have to improve the accuracy.
Now we will do a quick demo of prediction part. And here is the CSV file, and we store the data that we want to predict in this CSV file, there are 8 instances, and each with 10 main extracted features, and the result is here. We use the first 4 is the male and the last 4 is female, so we want to predict this result. And first we will delete it, and we will run the Python script. And here's the outcome. We can see that the first 4 is male and the last 4 is female, which is the same as the result here. So because the accuracy of our algorithm is already very high, so the prediction is always very accurate. So that's all about our project. Thank you.